So continuing and taking a look at its function, right? We have the integral from pi over 6 to pi over 3 of secant squared theta d theta, right? Again, what will our u be, right? We're using u substitution to solve these problems. What will our u be? Well, to think of it, right? You want to look for things that are derivatives of each other. Well, in this case, I can't set u is equal to secant of theta, because when I take the derivative of secant of theta, I get secant of theta tangent of theta, right? So that would make any sense. All right, so what else could we set it to? I am thinking that maybe, since this is secant squared of theta, maybe I could set my u to be theta, right? Generally, your u will be things that are in brackets. Now, this problem doesn't come with any brackets, but again, it should be helpful to know that a lot of times when we say cosine of x or cosine squared of x, those x's are always in brackets, or cosine squared of something, they're in brackets. Sine squared of whatever, tangent of whatever, they're always in brackets. So in this case, secant squared of theta, the theta is actually in brackets, but it's not shown explicitly, right? But this is the only way to go, right? Because now, if u is equal to theta, and the derivative of theta is just 1. So now we have 1 dx, 1 d theta. We're dealing with theta. I'm sorry about that. So we got to take the derivative with respect to theta. So now we have 1 d theta. And this is exactly what we have. We have 1 d theta here, right? So now that we have found partially our new substitution, here's the rationale I'm going to use. Since x is equal to pi over 4, u is going to equal to pi over 4. All I'm doing is plugging, well, since x is equal to pi over 4, then u is going to equal to pi over 4, right? Because all I'm doing is plugging in these values here in for theta, right? And since theta, and maybe I should use theta since we're taking the derivative and antiderivative with respect to theta, right? So since theta is equal to pi over 6, now we're going to pi over 6, right? Then u is going to equal just pi over 6, because all I'm doing is plugging in this theta value in for theta, right? So in this case, our integrals didn't really change. So this is now our new integration. So rewriting our integral, this will be an integral from pi over 4 to pi over 6, right? Du is just 1 d theta, which takes care of this. So this now becomes secant squared of u, because we used our theta as u, du, right? So this will be our new integral. And now all we got to do is just take our antiderivative and plug in the values, right? So the antiderivative of secant squared of theta, well, that's just equal to tangent of u. And that will be evaluated from pi over 6 to pi over 4, my equal sign, right? So now I can just plug in these values in for u and evaluate, right? So this now becomes tangent of pi over 4 minus tangent of pi divided by 6. And this should give us an answer, our answer. Well, tangent of pi over 4 is just 1. Minus tangent of pi over 6 is 1 over the square root of 3. And I could just find a common denominator here. All right. And we get our answer to be the square root of 3 minus 1 divided by the square root of 3. Let's look at this one right here. The integral integrated from 3 to 4 of 1 of dx divided by x, x minus 2 squared. Well, again, I always like to rewrite my integrals, right, showing that I have a 1. So this is just 1 over x minus 2 squared dx. Yes, what will be my u? Well, I'm going to rewrite this again. Since I have a 2 here, I could flip this whole thing up in the numerator and give me a negative exponent, which is fine, right? So this will be equal to integral from 4 to 3 of x minus 2 to the negative 2 power dx. And these are, and this is a couple of tricky things with integrals. You got to find some way to kind of make them much more easier, right? So you could get to this idea of the x to the n plus 1 divided by n plus 1 root. So now my integral is in good shape. So now I could set my u to be whatever is in the parentheses, and this is not always the case, but most times, right? So this is just x minus 2. That will be my u, right? So my u will be x minus 2, right? du is just 1 dx. The derivative of negative 2 is 0. Derivative of x is 1. Now, again, the reason why we're setting u is equal to some value, the reason why we choose our u is because we want to find something that when we take the derivative of u, we get something that's already there in the original integral. So notice when I take the derivative of x minus 2, I get 1 dx. We have 1 dx that is already there. And that is the trend. That is the kicker you got to get over when you're trying to choose what will be your u. Right? So du is just 1 dx here. So again, I'm going to use my rationale. And so since x is equal to 4, then u has to be equal to 4 minus 2, right? And since x is equal to 3, then u has to be 3 minus 2. And that is just equal to 1. This is just equal to 2, right? So this will be my new integration. Now I'm now taking the integral from 1 to 2 of u to the negative 2 power du, right? And that is my integral in the simplest fashion, right? Because again, stemming from here, our u is this. Our u is raised to a negative 2 power, right? And we now got our new integration values from this rationale that we've created here, right? Make sure integral is much more simpler. And now we can just take the antiderivative and evaluate, right? So again, the antiderivative of u to the negative 2 power is just u to the negative 1 divided by negative 1. And this will be all evaluated from 1 to 2, right? Equal sign. And now we can just plug in our values. Now I'm going to factor out my negative here, right? So negative u to the negative 1/2 power to the negative 1 power is going to be evaluated from 2 to 1. And that is just equal to negative, well, 2 to the negative 1 power minus 1 to the negative 1 power. All right. Well, notice that this 2 is raised to a negative 1 power. So really, this is just 1/2. I could just flip the 2 in the numerator and get it to a positive exponent. So this is just equal to negative 1/2 minus, well, 1 divided by 1 is just 1, right? 1 divided by 1 is just 1. And now, because of good stuff, we might find a common denominator, right? So really, or not yet, we can distribute this negative first, right? So this is just negative 1/2 plus 1, right? And you could imagine negative 1/2 plus 1, that is just 1/2. So this will be your integration value.